Hello, my name is Andy Banna, and I did a data visualization over Seattle weather in the year of 2016 for my final project in MSDS 696. The main question I wanted to research throughout this project is how close can we get to estimating and predicting the temperature on any given day while having access to the max daily temperatures throughout the course of a year. The data that I used was compiled over the course of a year in Seattle, Washington. It was 2016. As you can see on the slide, the type of information that was included in the data set. So we have the month, the day, average and actual temperature, what the forecast predicted, how accurate that was, and then also temp 1 and temp 2 represent the max temperature from the previous 2 days in the year. After I had cleaned the data, I established an average baseline error as a way to compare the accuracy of the model that I created versus the initial data. If the model's prediction proved to be a little bit closer to the actual temperature, that's how we prove success in this project. The average baseline error, as you can see on the right, is about 5 degrees. So we're shooting to create a model that gets us a little bit closer and has a smaller margin of error. In terms of our results, the model I created proved to be pretty accurate. As you can see, it says 99.77% in predicting temperature. The model I created was only about 0.15 degrees off the actual max temperature. You can see on the right there is a data visualization about the actual versus predicted, and as you can see, the red dots, which represent predicted, are virtually right there, right on top of each endpoint on the lines. Continuing on with the results, this is where I ran into a little bit of trouble with the project. As you can see on the left, the actual max temperature and variables graph, actual temperature and temp 1, which represents the temperature of the day before, are virtually exactly the same. They overlap each other for the whole course of the year, maybe a few small spots here and there. But in my RFR, you can see that actual temperature is the most important variable, far ahead. There's actually nothing else there. So this is where the project, I had a little bit of trouble with the project. According to the RFR, actual temperature is far more than the indicator, but as you look on the graph here, it ends up being temp 1 that seems to be most accurate. Overall, it was a pretty successful project. The model created was spot on, but I wish I could have been a little bit better in terms of proving variable importance. Thank you.